Thank you for tuning in. Again, this is Orbit Network Training, Connected Orbit to Software, Part B, running the Orbit Library test. So the next step we're going to do is just go through the Orbit Library test, which is this software pack up here. This is a good program to use. Again, it's one that incorporates all the different library commands of Orbit, but it's also a solid program to use to check on your interface modules as well as check on the function of the probes themselves. It also demonstrates the different reading modes that Orbit offers. So the first thing we're going to do when opening it is click Connect. Make sure you have an interface module and at least a probe or other sensor connected. So now if you'll see, I have a USB interface module connected up here, and that's the serial number there. With it highlighted, you'll see a tab up here, and then this is information for that particular interface module. If you'll see, it'll have the interface speed, the maximum number of modules, but it also shows the different network modes and its capabilities. For a USB interface module, of course, it can run buffered, dynamic, dynamic 2, and read burst. For an RS-232, for example, it would probably show false for dynamic as well as dynamic 2. It also shows the different network speeds that you have for it. Now we're also going to take a look at the probes that are connected to it. For that, you can click Ping. And again, Ping is just a simple command to see what is on the network. You can also do Notify Add Module, and that's where if you click that button, you then press a probe tip for each module you wish to add. So now we have two probes on this network. I'm just going to highlight the first one here. You'll see now you have a series of tabs up here. So now we're just going to click on the second one here. Click Module. And if you'll see here, this gives all the particular information about this particular digital probe. Here's its identity, module type, DP. Here's the part number, 971-200-DT2S. The software version. This actually means the firmware version that is loaded onto the Orbit module itself. Measurement range, and units measured. And then it shows the different capabilities. It can run in dynamic, dynamic 2, as well as read burst. Then there's a couple of simple features. If you'll notice here how it says reading, if I just click read, it's going to show you the reading right there. And then if I click start continuous, and then move the probe up and down, it's taking a real-time live reading of the probe. This is something that can be helpful if you wish to just test out the function of a probe while you are in the field. Now, if you'll notice too, you can actually read in units and counts. Basically, how the digital module works is that it converts the signal from the probe to digital bits and then scaled to the unit of measure. In this case, it's scaled to 2 millimeters. So if you switch to counts, and then let's click Start Continuous, see how now it's reading about, from about 7,700 bits to about 13,000 bits as I move the probe. Now that leads to the next display over here, resolution. Basically, notice how it's listed in 14-bit, 16-bit, or 18-bit. That has to do with the number of bits to define how high a resolution you can go. And when it says 14-bit, what that actually means is 2 to the 14 bits, which would be 16,384 bits. Now if I click Start Continuous again, and then move the probe tip all the way to the end of its range, what's it going to finish at? About 16,384 bits. Now those are about the number of many times the reading can change across the measurement range. If you go to 16-bit, then those number of bits goes to 65,536. So let's change this to 16-bit real quick. Click Set. Now we'll click Start Continuous again. Notice how now the reading has gone up to about 29 to 30,000 and can go up to 65,000. So this is one way where you can actually increase the resolution. But it should be noted that 14-bit is more than adequate for the applications that you're looking at, given that it gives you the capability to have a resolution down to 5 decimal points. Then the next thing you see here is averaging, which is currently at 16. To explain averaging, we need to explain the function of the digital probe and its module a little bit more. Basically, the Orbit module takes an electronic signal from the probe, which goes through an analog to digital converter. The sensor signal is on a high-frequency carrier and is first extracted from this. But this process requires an analog aliasing filter before the signal is passed to the A to D converter. This is to prevent higher frequencies from coming through and creating false data. Now, another way we filter that signal is through averaging the data from the A to D converter. By default, it is set to 16 samples. This is more than sufficient for dynamic or static situations. But if you are doing, say, a long-term test, such as monitoring a crack on a bridge over several days or several months, you can actually increase the averaging to 256 if you would like, which prevents transient changes showing the overall trend of measurement. But however, you could also reduce the averaging to 1 bit, and that makes it more sensitive to small transient changes. So for instance, if you are using a lever probe and you want it to be more sensitive to surface changes, you can reduce the averaging to 1, like shown here. But we're still going to leave it at 16. Now, one other thing worth noting too, that is if you set up like a third-party module or a DIOM, the setup information will actually pop in this void over on the right-hand side here. For example, these are the types of settings you would see for the DIOM2. Now, another feature too is in the upper right-hand corner here, the module status. You'll see there's a status hex, error code, and error code text. This can be helpful, especially if you're getting perhaps a red blinking light, but you're not quite sure what the problem is. If you click here, get status, so for example, here right now the probe is under range, the error code comes back 2112. There's actually a particular error code for several different types. So if you actually go to the Orbit software manual, you'll see an entire list right there as shown on the right-hand side. This is also something where a command can be sent to the module and it will send back an error code, so you can even find out in your own software package. So the next thing we will discuss are the different measurement modes that you see up on the tabs up here. First is buffered mode. As explained before, buffered mode is actually an old mode that came out when Orbit was first released. In essence, the Orbit module can actually store a few thousand readings within the module and then be extracted on command. This was something that was offered back in a time where computers probably couldn't take in the data fast enough. Nowadays, with Windows 10 computers and the current processors, they can easily operate dynamic mode and take the readings in no problem. But still, this is one particular tab that is, or feature that is still offered. Then we have difference mode. Again, the Orbit module can track the maximum, minimum, and difference and also be extracted on command. So we'll just demonstrate it here. I'm just going to click Enable, and then I will click Start Difference Mode. So now if you'll see the maximum and the minimum, as I move the probe up and down, you have a minimum reading, maximum, then the difference calculated right there. So now we'll discuss dynamic mode and how to set it up. If you'll see, there's a bunch of different commands and bubbles over here. We'll just first start with rate, and this is of course the rate in which you want to record the data. You have some standards here, such as 4,000, 2,000, or 1,000 readings per second. Now this can be done with just regular mode or regular dynamic mode. Then you have dynamic to custom. This is something you can do with dynamic to mode. And here you can just basically change it where if you want to do, say, 3,500 readings per second or 1,500 readings per second, you can tweak it to that. Now the first thing you have to do though is let's go back to the USB and make sure that we go to ultra high network speed. If you're in low, dynamic mode will not function. So once we're set with that, go back to dynamic. And if you'll see here, it says interval, and this is in microseconds. You know, 1 microsecond is 10 to the minus 6 seconds. So for this, you probably want to do at least 300 microseconds in between readings, because the Orbit modules themselves can only output about 3,906 readings per second. Now, if you'll see here too, number of syncs. So that's, let's say you want to record 10,000 readings, for each module. Here, then you would plug 10,000 like that. Now, if you just want to continue to record readings until you click the stop button, you just leave this at 0. Then it says here sync mode, normal or external. Normal is where you just have a computer or whatever device you have hooked up to Orbit. That is what triggers the dynamic readings. But for external, this is where you can use a digital input-output module, or a DIOM2, where you can use an external switch to trigger the dynamic readings, or you can use the encoder interface module for applications like the picture that you see there. You can have a rotary encoder trigger the dynamic readings. So for example, on an application like that, where you want to have all the readings at 1 degree, all the readings at 2 degrees, all the readings at 3 degrees, as a shaft rotates for the probes, this is something where you can use a rotary encoder, an encoder interface module, and tie that into orbit and have that trigger it. Right now we'll just do this with normal. Then you have the module list. This is where you want to select the number of modules that you have in your collection. Here we'll just do 2, since we have 2 probes set up with the network. And then down here, once you have this all set, click Enable, then Prepare. Then once you are all set to take readings, click Start. Now I'll click Stop, and then just click Display Readings. So then once the results are loaded, and this could take a little bit of time, you'll see that you have results listed for the 2 probes that we have set up here, and it goes from 0 all the way to about 32,000 readings. So this, even if you just want to use Orbit Library and take some basic measurements, you could just basically take this and cut and paste it into an Excel spreadsheet if you wish to do any type of measurements. So then the final tab is read burst mode. Now again, read burst is basically, if you send a read burst command to the Orbit network, it will send back one single dynamic reading of all the probes and all the modules on the stack. So this is something that's a little bit handier where if you want to do a dynamic reading but don't want to go through all the setups, basically what you can do is have your computer or whatever device you have hooked up to the Orbit network and just have it rapidly send the read burst signal. Now there's certainly a limit to how many read burst commands you can send to the Orbit per second, and this is where this particular tab can help. If I just click Time Readings and give it a second, you'll see here with 2 modules you can have 4,230 read bursts per second. So the total number of module readings per second is 8,460. So if you have a computer that's capable of sampling that fast with the read burst command, you can certainly do that here. So for the library test, it should be noted again that you have the library test here, and then this is the library test project that you can use in Visual Studio. And again, that is shown here. So that concludes part B of the training. For part C, updating an Orbit module, again, click the eye in the corner or just stay tuned, as this should be the next video in the playlist.